Alright, for each of the following, we need to do the following. Right, and in behavior model, evaluate each limit and determine whether or not there are horizontal asymptotes. If so, what's the equation? Or determine if there are slant asymptotes, aka oblique asymptotes. I've not really heard anybody call them oblique asymptotes, but you know, it's just good. It depends on what professor you have. If so, what's the equation? Alright, so in behavior models, all that we care about are my lead terms. So all that I really care about is this. Why did that one just disappear? 2x over 3x squared. To find that in behavior model. Let me get out of my highlighter again. So I'm going to have 2x over 3x squared. One of these x's is going to cancel out, leaving me with just 2 over 3x. And then I see, as I plug in bigger and bigger numbers for x, my denominator is going to grow faster, so that would be 0. So therefore, the limit of this whole thing is also 0. Alright. Determine whether or not they have horizontal asymptotes. If so, where? The equation would just be y is equal to 0. For my horizontal asymptote. Alright, next one again. All I care about is this lead term. So I would have 2x squared over x squared. Well, the x squared is going to cancel out, leaving me with just 2. That is my end behavior model. So the limit as x goes to infinity is also going to be 2. Alright. So then this whole limit is also going to be 2 because even though this has another x in it, just like the previous one had another x in it, I just forgot to mention it, this is going to be growing significantly less than this. X squared is always going to be growing faster. That's why I don't give a crap about the other x's. I'm sorry, I should have mentioned that before. Alright, and then what that means is that I am going to actually have a horizontal asymptote. Therefore, is what that 3 dots means. Therefore, I have a horizontal asymptote at y is equal to 2. Nice. Alright. And then finally on C, I actually had to look back at this one, and he ended up changing it because it became gross. And let's just do the same thing because the person who made these notes was like, this is yeet and delete. Alright, so let's try this being x squared plus x plus 9 all over 3x minus 3. Because like I said, this one ended up gross. I got rid of it, and bleh, I tried. It was gross. Alright. So, the limit as x approaches infinity, my end behavior model, the first thing I'm going to do, again, is just, hope this shows up. I'm going to take x squared over 3x. Didn't want to use green, I was gonna, but green on green would be disgusting. Give me back my pen. Thank you. I'd have x squared over 3x, which is just going to simplify to being just x over 3. And then I see, my numerator is going to grow and grow and grow and grow and grow and grow faster, meaning that my limit as x approaches infinity of x over 3 is infinity. So therefore, the limit of this does not exist because it's going to keep growing. Without bound. Alright, so bounding is just when you come up to a certain point and that's the highest point you have, that would be called bounded above. And then if you have the lowest point, that would be bounded below. So like parabolas are bounded below because you can't go below the vertex, or if you have a negative parabola, you'd be bounded above because you cannot go above this point. And if you're not bounded at all, you're not bounded above or below. Just a little refresher. I know I talked about that a little bit last year, but that might not have made a whole lot of sense last year. Alright. So what I have to do now is, if I do not have a horizontal asymptote, I have to determine if there's a slant asymptote, which involves our favorite thing, long division. It's actually the thing that I usually try to forget about, to be honest. Alright, so long division, I've got 3x minus 3, x squared plus x plus 9. Oh, jeez. So I should get 1/3 x, because I'm trying to say, what do I have to multiply 3x by to get this x squared to go away? So I'd have to get rid of that. So I have x squared now minus just x. So I'd subtract those, subtracting down. I should get negative times a negative should be positive, so that's actually 2x, as I kept thinking for a second those are going to cancel. They didn't. Alright. And then, oh jeez, fun times. What times 3 gives me 2, which would be 2/3? Yes. Alright, 2/3 should be 2x minus 2. Again, just subtracting down. So that's actually going to be 11. Alright, so what I've actually got is that so now my limit, as x goes to infinity, for example, should be this 1/3x, and I'm just going to write that up in the numerator, plus 2/3 plus 11 over that original denominator, which is 3x minus 3, because we did not get rid of it, so it should be written over the original. Alright, but what's going to happen, oh my gosh, is that this 11 over 3x minus 3 ends up having an x in the denominator, so that's actually going to trend towards 0 and not really end up mattering. So all that I really need to know is that my slant asymptote is just this piece that's not going to go to 0, which is 1/3 x plus 2/3. That's it. That's my slant asymptote.